There is a liquid that stands up when you bring a magnet near it. Not ripples, not a bulge. It grows a forest of perfect black spikes, arranged in a pattern so precise you could calculate it with an equation. It looks like special effects. It looks like something that should not be allowed to exist in a bottle on a desk. And the strangest part of the story is not what it does. It is where it came from and where it ended up. It was invented at NASA in the 1960s to solve a very specific problem with rocket fuel. It never flew on a single rocket. Instead, it quietly moved into your house. It is almost certainly inside the speakers you are listening to me on right now. It spent decades inside nearly every hard drive on Earth, and there are doctors testing it as a way to steer chemotherapy through your bloodstream to a tumor and nowhere else. This is the story of the strangest liquid humans have ever made, and how a failed rocket experiment ended up in a billion living rooms. Let's start with the problem NASA actually had, because it is the kind of problem you never think about until you leave Earth. On the ground, fuel behaves itself. Gravity pulls it to the bottom of the tank, the pump sits at the bottom, and the pump gets fuel. Simple. In orbit, there is no bottom. Fuel in a weightless tank does not sit anywhere. It drifts. It clings to the walls in sheets, it forms floating blobs in the middle of the tank, and when the pump switches on, it might get liquid. Or it might get a mouthful of vapor, which is a very bad thing to feed an engine you are relying on to get home. Engineers had ugly workarounds. Fire small thrusters first to shove the whole spacecraft forward so the fuel sloshes to one end. Put a flexible bladder in the tank and squeeze it. Both work. Both add weight, moving parts, and new ways to fail. So in 1963, an engineer at NASA named Steve Papel asked a different question. What if you did not have to chase the fuel around the tank? What if you could just reach in with a magnet and pull it where you wanted it? The obvious objection is that fuel is not magnetic. Neither is water or oil or almost any liquid you have ever met. His answer was, then let's make it magnetic.
Here is the trick, and it is more elegant than it sounds. You can't just melt a magnet. Heat a piece of iron enough to turn it into liquid, and it stops being magnetic entirely. The temperature scrambles the internal alignment that made it a magnet in the first place. So Papel went the other direction. Instead of making a magnet into a liquid, he put solid magnets into a liquid. He ground magnetite into particles about 10 nanometers across. That is small enough that a single grain contains only a few thousand atoms, and small enough that the random jostling of the liquid's own molecules keeps them permanently suspended. They never settle the way sand settles in water, because at that scale, they are being kicked around faster than gravity can pull them down. But there is a catch, and it is the catch that makes this hard. Magnetic particles want to stick to each other. Left alone, they clump into useless grit within minutes. So every single particle gets wrapped in a molecular coating, a layer of long, slippery molecules that keep the particles from ever quite touching. Get all three parts right, particle size, coating, carrier liquid, and you get something genuinely new. A liquid that responds to a magnet as a whole while staying perfectly liquid. Pour it, splash it, spill it. It is a fluid in every way, right up until a magnet walks into the room. And then you bring the magnet close, and it does the thing. The spikes are not decoration. They are the fluid solving a maths problem in real time. Three forces are arguing. The magnetic field wants the fluid to pile up along the field lines, stretching upward. Gravity wants it flat. Surface tension wants the smallest possible surface area, which also wants it flat. Below a certain field strength, flat wins and nothing happens. Push past that threshold and the magnetic force overwhelms both, and the surface breaks into the most efficient possible compromise, a repeating array of peaks. The shape is called the Rosenzweig instability, and the spacing between spikes is not random. It is set by the properties of the liquid, and you can predict it on paper. Which means when you watch a ferrofluid spike up, you are watching an equation happen. Now, the twist. NASA never used it. The fuel problem got solved other ways. Bladders and settling burns turned out to be good enough, and nobody wanted to fly a tank full of experimental magnetic sludge. The idea sat there, a solution that worked beautifully, attached to a problem that had already moved on. That could easily have been the end, a curiosity in a patent file.
What saved it was a completely different property, and one nobody was excited about at first. Ferrofluid stays exactly where you put it. Take a spinning shaft passing through a wall, the wall of a vacuum chamber or a sealed hard drive. Sealing that gap is a genuinely annoying engineering problem. A rubber seal touches the shaft, so it creates friction, generates heat, and wears out. A gap with no seal lets contamination through. Now, put a ring magnet around the shaft and a drop of ferrofluid in the gap. The fluid locks into place in the field, forming a liquid ring that completely fills the space. And it stays there because the magnet will not let it leave. The shaft spins freely through it. Nothing touches, nothing wears, nothing gets past. For decades, that seal sat inside hard drives, keeping dust away from platters spinning at 7,000 revolutions per minute, where a single speck of dust is a catastrophe. It is in semiconductor manufacturing equipment and in vacuum systems where a leak means starting over. And then there is the one in your room. Look inside almost any loudspeaker and you will find a coil of wire sitting in the gap of a permanent magnet. Music is that coil pushing back and forth, but a coil carrying current also gets hot, and heat is a speaker's enemy. It changes the sound, and eventually it kills the driver. So somebody realized there is already a strong magnet right there. Put a drop of ferrofluid in the gap and it stays put, in permanent contact with both the coil and the metal around it, carrying heat away far faster than air ever could. It also damps unwanted resonance, and it costs almost nothing. Hundreds of millions of speakers have been built this way. A failed rocket experiment is in your headphones, your car doors, your television, doing a quiet job, holding on with nothing but a magnetic field.
Which brings us to where this is going. And this is the part that could actually matter. If you can steer a liquid with a magnet from outside the container, then you can steer a liquid inside a human being. Chemotherapy has a brutal design flaw. You put poison in the bloodstream, and it goes everywhere. The tumor gets some, so does everything else, which is where the side effects come from. The idea being tested is to attach the drug to magnetic nanoparticles, inject them, and hold a strong magnet over the tumor. The particles concentrate in that region, so the dose lands where you want it, and the rest of the body gets less. In animal studies, this works. Human trials are ongoing, and it is genuinely hard. Magnetic fields fall off fast with distance, so reaching a tumor deep inside the body is a real problem, not a detail. A related version is already routine, though. Those same coated iron oxide particles are used as contrast agents in MRI scanners, making certain tissues light up. And there is a treatment called magnetic hyperthermia, where the particles are injected into a tumor and then hit with a rapidly alternating field. The particles cannot flip fast enough to keep up, and the lag turns into heat, cooking the tumor from the inside at a temperature the surrounding tissue survives. There is also a strange, delightful branch, soft robotics, blobs of magnetic fluid that can be steered through a tube, change shape, split apart, and merge back together, all from outside. Researchers have driven them through models of the digestive tract to deliver a payload to one specific spot. Every one of those applications traces back to a tank of rocket fuel that nobody could pour.
So here is what I actually take away from this. Steve Papel solved his problem. He built the thing, it worked, he patented it, and then the mission requirement it was designed for evaporated. By the only measure anyone was using at the time, that project failed. 60 years later, his failed invention is in your speakers, it was in your hard drives, and it might one day be threading chemotherapy through someone's bloodstream to exactly the right place. The invention was fine. The problem it was aimed at was just the wrong one, and it took decades for the right problems to show up. If you like the idea that the useful thing and the intended thing are often not the same thing, stick around. Next time, we're going to look at a lamp that floats in mid-air above its base, with nothing holding it up, and a mathematical theorem from 1839 that proves rigorously that what you are looking at is impossible. The lamp is not breaking the theorem. It is cheating, and the way it cheats is the same technology as a 600-kilometer-an-hour train. Subscribe, and I'll see you there.